Hi everyone, we are Group 18 from Section 4. This is our video for e-service learning for communication principle. Our title is Phase Modulation. This is our group member. And modulation is a process of shifting the frequency of message signal to high frequency. For example, a voice is too big and slow, and a high frequency wave is fast and small, so we combine them to become usable. This is because we want to transmit signal over a long distance and so on. And for analog, we have two types of modulation, which is amplitude and angle modulation. And in angle modulation, we have frequency modulation and phase modulation. We only focus on phase modulation today. So phase is a position of a rotating object. So for phase modulation, the phase is changing depending on the amplitude of modulation signal. And the phase duration is proportional to the modulating signal. And the change of phase can alter the frequency, means there will be a little bit overlap between FM and PM. But the main difference here is FM only focus changing the phase rather than frequency of the carrier signal. So the frequency and amplitude is remain the same. In a conclusion, PM change the position, which is angle of a wave to represent the information. This is the overview of phase modulation.
Let me introduce some basic mathematical models. This is the equations for the unmodulated carriers, and this is the formula for the phase deviations, which is phase deviation constant in radians per watt multiplied by the message signals. As we know that the instantaneous phase formula is this, then we sub the phase deviation into this equation, then we can get this. Then we sub the instantaneous phase into the unmodulated carriers, then we can get the modulated signal equations. Now, I would like to talk about the relationship to frequency modulations. Phase modulation and frequency modulations are closely related forms of angle modulation and are often distinguishable without knowledge of the original message signal. For the instantaneous frequency, this process shows the in PM, the instantaneous frequency varies linearly with the derivative of the message signal. For the interconvertibility, a phase modulation signal generated by message signal is equivalent to an frequency modulation signal generated by the derivative of message signal. If let's say the message signal enter to the frequency modulation, then it will become the frequency modulation signal. And if let's say the message signal enter to the phase modulation, then it will become the phase modulation signal. We have two general equations, which is from the phase modulation and the frequency modulations. And we let the x equal to derivative of a message signal, and then we sub into the equation, and then we can get this equation. Now I would like to talk about the key characteristic, constant powers. The constant power is constant and independent of the message signal, unlike the amplitude modulations where power varies with the message signal. For the modulation index, we know that the modulation index is equal to the phase deviations equal to the Kp multiplied by the Am. And it can prove that the modulations for PMs is independent of the modulation frequency. Non-linearity, which is phase modulations is a non-linear process. If the message signal is the sum of the two sinusoid, then it will become this, like this. And then we use the cosine addition formulas, and then we take off the center part to apply the Bessel function expansions, and then we can get these equations. The resulting spectrum contains components at these equations, where the n and m can be non-zero simultaneously. If modulated by omega 1 alone, the spectrum will be like this. If modulated by omega 2 alone, the spectrum will be like this.
Now have a look at spectrum and bandwidth. Strictly speaking, angle modulation generates an infinite number of sidebands due to its nonlinear nature. However, sidebands further from the carrier frequency decrease in amplitude, so we only consider the effective bandwidth where its significant power lies. On the Bessel function table right here, as we can see that when the modulation index is small, for example, equal to 0.5, only the first sideband pair is significant. As the modulation index increases, high-order sidebands gain more amplitude. This explains why wideband space modulation requires more bandwidth compared to narrow band phase modulation. The signal is called narrowband phase modulation if the peak phase deviation is very small, which is much less than 1 radian. Its spectrum resembles amplitude modulation consisting of the carrier and one pair of sidebands. The key point is that the lower sideband phase shifts by 180 degrees compared to amplitude modulation. For the wideband phase modulation, when the phase deviation is large, the bandwidth is approximate using Carlson rules. This gives us the effective bandwidth containing most of the phase modulation signal power. There are several techniques to generate phase modulation. One way is by feeding derivative message signal into the voltage control oscillator. Another way is by using narrowband phase modulation generator. Phase modulation demodulation is generated using phase load loop or PLL. Now have a look at comparison between amplitude modulation and angle modulation, which shown in the table right here. This table shows that the comparison between frequency modulation and phase modulation. The two figures right here show that the FN have wider bandwidth compared to that of phase modulation. Theoretically, phase modulation has better signal quality with better signal-to-noise ratio compared to that of phase modulation. There are several phase modulation applications. Firstly, wireless communications like phase shift keying. Secondly, audio transmission in FN broadcasting. Thirdly, satellite communication in telemetry systems. And finally, navigation systems like GPS.
Hi everyone, I'm Gan Yihao. Thanks for my teammate explanation. Now I'm going to briefing about the recent advancement in communication field for the 5G. So what is the 5G? It's not just a faster internet for your phone. It's a massive network designed to connect the machines, cars, and the sensors. So what actually makes the 5G different from 4G? It comes down to three things, which is modulation, spectrum, and architecture. First, remember how we learned about shifting the phase? The 5G will take that to the extreme. It uses 1024 QAM, meaning it shifts the signal to 1024 specific position to carry way more data per second than 4G ever could. Second, it uses the millimeter waves. They are the high frequency waves that allow us to use the massive antenna arrays, called the massive MIMO, to send focus beams of data to individual users, rather than broadcasting in a circle like a radio tower. Finally, the 5G can slice the network. It gives a dedicated zero delay lane to a surgeon robot while giving a high-speed video lane to your phone. The 4G forced everyone to share the same lane. Why that? This matter to the society. This advanced modulation gives us ultra low latency. This means a self-driving car can react a hazard instantly, or a doctor can control a surgical robot remotely. This is a practical application of the phase modulation theory we just learned. So before we finish, let's address a major misconception you might hear in the news. Is this the technology safe? Myth number one, high number 5G is a dangerous radiation. In reality, absolutely not. Remember what we just learned in the class? Phase modulation only will change the timing of the wave. The angle, it keeps the radio constant. It doesn't suddenly turn a radio wave into a laser beam or on an X-ray. It's just a standard radio wave that vibrates differently. Myth number two, 5G will destroy the environment by using too much power. In reality, actually, it's the opposite. Because phase modulation transmits at a constant power envelope, the transmitter operates very efficiently. We don't need to pump up more energy to send more data. We just shift the phase more precisely. This makes modern network much more energy efficient per bit of data than the older network. That's all for our good. Thank you.